So this one says, determine the volume of T23 for the following sequence. And remember I told you that all of these are arithmetic, but I wouldn't actually have to tell you that this one is arithmetic. You could figure it out yourself, right? You could do term 2 minus term 1 equals term 3 minus term 2 equals term 4 minus term 3. And if you subtract them and they all equal, they have a common difference, which means they're arithmetic. So my D value would be 15 minus 8, or I could have said 22 minus 15, or I could have said 29 minus 22. All of these are 7. So that's how I know it's arithmetic, right? Because when I subtract them, I get the same D value. We agree? Then I want T23. So that's the only unknown I can't have. And if it's T and it's arithmetic, I only have one formula I can use. It's Tn equals T1 plus n minus 1d. So I need to know what T1 is, I need to know what n is, and I need to know what d is, right? Because the only one I can be missing is one unknown, and that's what it's asking me for, is T23. T1 is what in this sequence? What number? 8. And n, what am I asking you to find? 23. And d we found out was 7. So we're going to do T23 equals 8 plus 23 minus 1 times 7, which equals 8 plus 22 times 7, which equals what? That's my 23rd term. 162? Is that what people said? We're all in whisper zone, so I can't. I'm like reading lips. That's what's happening. There's a little bit of a whisper tone. All right. The next one says, a sequence has the following values, term 5 and term 8. 1, 2, 3, 4, 5. Term 5 is 4. 6, 7, 8. Term 8 is 16. So I gave you 2 terms separated, not a series, 2 terms separated, correct? And they're not the first term. When I do that, we always take a piece of the 2 terms, right? So we practice. We know. We get to unit test. We know what to do here. We don't freak out and say, I don't know what to do. You don't guess and check for 27 minutes. Oh, those are painful. Don't be those people. The guess and checking people for 27 minutes to see what numbers would fit. Okay? Yeah. All right. So we take a portion. We treat this like our term 1, which is 4. We treat this like our term 4, which is 16. So we have an n of 4. And why do we do this? So we can find what missing value? D. And when we have D, we can just add, boom, 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 done. Go the other way, boom, 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 subtract. Right? Okay. So we can go Tn equals T1 plus n minus 1d. Tn is 16. It's my last one. T1, my pretend T1 is 4. Plus, I don't take 8 because I'm only looking at 4 of them, right? 4 minus 1, d. So I get 16 equals 4 plus 3d. Subtract 4. 12 equals 3d. Divide by 3. And d equals 4. So then I can add 4 to get to the next ones, but I want term 1. So instead of adding 4, I'm going to subtract 4. So I'm going to get 0, negative 4, negative 8, negative 12. Could I now have used the formula to solve for T1? Yes. My last term would still be 16. The only thing that would change is n would be what? If I was serving 8. Because I would have 8 terms to look at, right? If I was treating that as my term 1. So when I use a formula to find term 1, I have to remember that my n is going to change. I had 4 here, but my term 1 actually has 8. Okay? How'd you guys do on that one? Good? So here it says calculate the sum. So I told you these were arithmetic. If you didn't know they were arithmetic, it didn't matter. You could go 80 minus 72, which is a lie. It would be 72 minus 80. so negative 8, or 64 minus 72, which is negative 8. So I know it's arithmetic. I didn't have to be told it was arithmetic. I told you it was, but I wouldn't have had to, right? As long as I have terms following each other, at least 3 in a row, you can tell me if it's arithmetic or geometric. All right? Okay. I want the sum. Now, there's 2 formulas for sum. The first formula, when I have the last term, I use it. The second formula, when I don't have the last term. Correct? Did I give you the last term? Yes. I gave you the last term. So I know I'm going to use Sn equals n bracket T1 plus Tn divided by 2. So I'm going to find I don't have n. What am I going to have to do? Find n. Did I tell you there's going to be a test question like this? Yeah, I did, because it's true. So there is going to be a test question like this, where I give you the first terms, the last term, ask you for the sum, and the first thing you're going to have to do is find n, which means we have to use the Tn formula, right? I know it says sum, and that's lovely, but we have to use the Tn formula to get n first. Yo. Ah, rip off. I told you. That's disappointing. This good. Thank you. You reassured that it was 15, didn't you? You're awesome. Awesome. Awesome people. That's what we are. We don't read. That's really smart of us. Reading comp is real high in our 2 categories. So I gave it to you. Man, was I nice. Kind soul, here I am. You're welcome. Jeez. Probably not going to happen on the test. Might, because I didn't even notice I did that for you. Look how nice I was. Seriously, sometimes I had a... Okay. You're welcome. Didn't even know I was that kind. 15. T1 is 80 plus negative 32 divided by 2. And we get what? 360?
Yeah.
Which is the number of degrees in a circle. That was just a side note to sidetrack you that I didn't realize I gave you the total number of terms. So yeah, 360 is a lovely number. You can go in a circle, 360. Add a degree to that bad boy. You don't want to do that for this though, because it makes no sense. But yeah. I didn't even know I gave you the total number of terms. On the test, I won't. For one question, for sure. Okay? It's gonna happen. Okay. All right, number 4. An arithmetic series has the following properties. S15, T15, D equals 1.25. So what the heck did they give us? They want term 1. They gave us the sum of the 15. They gave us term 15, so that's the last term of that sum, right? They technically gave us Tn. They gave us D. They want T1. What formula could we use? Does anyone know? There's 2 S formulas, right? Let's just write them out. Let's just see what they look like. Sn equals n T1 plus Tn divided by 2. Or we have Sn equals n divided by 2 bracket 2T1 plus n minus 1d. Which one could we use? Trick question. I was so kind, you could have used either. So you could have used this one and solved for T1 because it gave you the last term. Or you could have used this one, put in your D, put in your 15, put in your 15, solve for T1. I know personally which one I would pick, the easier one. But maybe you're like, easy schmeezy. I don't like it. What's up? So the Tn one you could have used too. Man, look how kind I was. Sweet gem of a child. Anyways, I would still choose this one because it's the easiest one. But, you know, look at that. Could have all used all 3. Could have been a rebel without a cause. Maybe you did use all 3. Maybe you're like, 1 equation? I'm doing 3. Because I'm not good. But I'm not. I'm lazy. So I'm going to do this one. So, S15 is that lovely ditty of a number. So if you're someone who's going to think you're going to guess and check your way out of this one, you could, technically. You could you do that?
Nope.
I think you're lying. All right. Fine. We'll get through it. T1 plus 34 divided by 2. Multiply by 2 and you get 700 and yeah, 757 point blah blah. Yeah, equals 15 times that. Remember, on a written response, when I say algebraically and you just subtract, you're getting no marks. I even give you 3 you could have chose from, right? Yeah. Divide by 15 and we get... Yeah, so I said 50.5. Totally. T1 plus 34. And then we subtract 34. And we get? Yeah. Voila. So the next one says, how many terms? How many terms is asking you to solve for? N. Yes, you're right, guys. Good answer. Thanks for your help. Are in the arithmetic series negative 18, negative 15, negative 12, 57, and 60, which actually should say sequence. We're not adding those. That's a stupid typo. Should say sequence. When there's commas, that's a sequence. And then they tell you if the sum of the series is 567. So if you actually summed this sequence, you would get 567. Right? So I'm asking you to find N. What formula are we going to have to use? You could just use the normal one, right? So we have Tn equals T1 plus n minus 1d. We know Tn is 60. We know T1 is negative 18. We know n is what we're finding. And we know d is negative 15 minus a minus 18, which is 3. And we can check. Negative 18 minus 3, negative, or plus 3, negative 15, plus 3 is negative 12, so it looks good, right? So we have the 3. Then we add our 18. 78 equals 3n minus 1. Divided by 3. 78 divided by 3 is 2, 6. Yeah. Add 1. N equals 27. So this was extra information, right? You still could have used it, though. You could have used the SN formula and got it, too. The first SN formula. So you could have went either way. All right? Good times. So we're going to do geometric notes. Go to. Now. So terminology, rate of growth, rate of decay, yep, decay, and percentage of. So 100% plus the percentage of growth equals the rate, equals the R, if it's word problems. Okay, if we're dealing with growth. If we're growing, 100% of the original is just the original, isn't it? Like if I had 5 fish to start with, and I took 100% of the fish I had, that's 5 fish, right? I haven't grown, I haven't decayed, I have 100% of the fish I had. So my initial value would be 5 fish, and I have 100% of it, correct? So if I'm growing, I have to take 100% of the fish I have and add the growth rate. That's why you do 100 plus the growth rate. 100% of the fish I have plus the growth rate. Okay? So we're going to look at an example here. The rate of inflation. Inflation is another way to say growth. Same thing. Or it says increasing. Those are hints that you need to add the interest rate onto it. Okay? So the rate of inflation growth is increasing by 3.5%. So people will tell me the rate is 3.5%. The rate isn't 3.5%. The rate is I take 100% of my fish and I add the 3.5%. Right? So 100% just means I didn't grow, I didn't decay, I'm just sitting with my fish. Hanging out, being cool. Shooting some people outside of the school. and a couple of guys. They were up to no good. Started making trouble in the neighborhood. Found one little fight. My mom got scared. Said, "Move with your auntie, not come back." I pulled up to the hospital. Oh, smell you later. Looking like King of Rose finally there. I said, "What's wrong with him? The Prince of Bel-Air." I can drop this one. I've already dropped it and wrecked it before, so it's fine. It's kind of wrecked. Just smooth it out. It's okay. All right. So our rate is 100 plus 3.5, which is 103.5, but that's percent. And a little percent symbol would look really stupid in an equation. Like it would look really dumb. Like you just have this percent symbol sitting in there, and you're like, why do I got a percent symbol sitting there? How do I use that as a unit? You don't. So we have to get that percent symbol to go bye-bye. So what we have to do always is we take this lovely 100 plus 3.5, and we have to divide it by 100, because that gets that little percent symbol to go bye-bye, which we don't like. And then that gives us what? 1.035. Which moves the decimal place 2 to the left, right? When you divide by 100, you divide by 10, it moves it 1 to the left. Divide by 100, 2 to the left. Remember the staircase? All kings do fine, or something. I don't remember. I'm totally squishing together the staircase and piano right there. Piano. Don't you remember? Like it's like.
I don't even know what the staircase is.
You know the staircase. The staircase where it's like millimeters, centimeters, decimeters, meters, hectometers, decameters, kilometers, and then you're like hectometers, decameters, meters, and it's in the staircase. Yeah, right. Well, you missed out. That's all I have to say. I don't even know how you guys are coping. You'll be okay. It's fine. You go up the staircase, you move it to the. Go up the staircase, you move the decimal places to the left. You go down the staircase, you move to the right.
There's never a staircase. We just turn
Staircase. It's good times. Well, you'll be okay. That's all right. We're not converting. Totally good. So, if it's growth, we take 100 plus the growth rate, correct? If it's decay, what do you suppose we might do? Subtract it. I know. It's fantastic. So, we're going to go 100% minus the percentage of decay. If it says decay or it decreases or it depreciates, those are all the same thing. Okay? So here it says the number of fish in a lake is decreasing. So here's my fish. The number of fish in a lake, my 5 fish, is decreasing by 2% each year. So my rate, what am I going to do? Oh, I have my 5 fish. Here's my 100%, right? And then I'm going to subtract off my 2%, which gets me 98% of the fish are left every year. So that 98% tells you what percentage is left. So that's a lot of fish still left, right? 98% of the fish I had in my little lake are still there the next year. And then the next year, 98% of that value is left. And then the next year, 98% of that value is left, right? So they're decaying by 2%. So this value doesn't tell you what it's decaying by, it tells you how much is left. Okay? Now remember, we can't put 100%, we can't put percent symbols in our formula. So we have to divide by 100. Where's the decimal on a number if it isn't looking, if I don't have it drawn? There? Yeah. And then I'm going to move it 2 to the left, which would get me 0.98. You really missed out. The staircase was a lot of fun. Yeah, Google staircase conversions. Fun times. All right, this one is a little bit different because it doesn't use percents. It says the value of a computer decreases by 1/5 each year. So 1/5 of the original goes bye-bye, which means how much of the original is still there? 4/5. Girl, you're doing good. All right. So how we can do it when it's a fraction is we could technically go 1 minus that 1/5, right? 5/5 would be the whole pizza. Like if I had a whole pizza cut into 5 pieces, which is really hard to do, just so you know, I would have 5 out of 5, right? So I'm taking 1/5 of that away. So how much pizza do I got left? 4/5, right? When you think of fractions in pizza, life is just way better. No jokes. Ever you have to deal with fractions, think of it in pizza. It just makes it so much easier, and you get a little hungry, but you be okay. I promise. So, make sense? Increasing, add the percent. Decreasing, subtract the percent. Fraction, think of it in pizza. 1/5 of it's going away, I still have 4/5 of it left, right? Percentage of. So this one says the number of rabbits in a population is doubling. If it says doubling, you originally have 100%, correct? That's what we said. So if it's doubling, I originally have 100%, but it's doubling. So how many percents do I got? I'm going to times that by 2, I'm going to have 200%, correct? But I told you can't fill the percent symbol into our formula, right? So what am I going to have to do? Divide by 100. So my rate is 2. The next one says the ball rebounds to 3/4 of its previous height. So this one says it decreases by 1/5, so I have 4/5 left. This one says it rebounds to 3/4. So how much is left? Nope. It rebounds to 3/4. How much is left? It's a trick question. 3/4 is left. R is 3/4. If it rebounds to 3/4, then the next one is going to rebound to 3/4, then 3/4 is left, right? So this one, when it says it decreases by 1/5, you actually have to subtract from 1. But when it says it rebounds to 3/4 of its previous height, 3/4 is left, then 3/4 is left, then 3/4 is left. So R is just 3/4. Kind of like your little helpful cheat sheet right here. Just can't take it on test. Okay. So we're going to look at this bad boy. A truck depreciates in value by 15% per year. Is it going down or going up? It's going down. And it's percent. So the first thing I'm going to get is my rate. So my rate is always 100 if I do nothing. But it's depreciating by 15%, so I'm going to minus 15. So it's going to equal what? Right here. 85, right? I'm not allowed to put percent signs in my equation, right? So what am I going to have to do? Divide by 100. So equals 0.85. We agree? Okay. Then it says the truck is valued at 40,000. That's actually term nothing. That's term 0. Okay? But we're going to treat it as term 1 because term 0 makes no sense. I have no formula for term 0. So term 1 is 40,000. In 2010. What will the value to the nearest dollar be in 2016? How many years is that? That's 6. You are always going to have to add 1 because this technically was term what? 0, and I'm making it be term 1. So I have to add 1 to my n in order for this to work, so I can use it that way. So my n for these word problems is always take your years and subtract them and add 1. Because remember, I need to count the end values. Remember we did that before with the other ones too? You counted, you subtracted the years, but you always had to add 1 to it because we needed to count those end years. Always. So you guys are always going to add 1 to your years when it's a word problem. So we go 2016, subtract 2010, which is 6, and then we have to add 1. So our n is 7, right? Now, whenever it's these R questions, it's geometric. It has to be. We're also in the geometric lesson, so it has to be. But when it's an R, it has to be multiplication, right? So it's going to have to be in the geometric lesson. Does it say anything about sums or anything? Are we dealing with how much the car added up to in 7 years? Which is weird. I don't know. No, it's TN. So we're going to go Tn equals T1 times R to the n minus 1. So it's going to be Tn, which is what we're finding, which would be T7 technically. We know what n is. Equals 40,000 times 0.85 to the 7 minus 1, which is 40,000 times 0.85 to the 6. You can type that in to your calculator. Everyone should type it in, because just because the person beside you can type it in doesn't mean you would get it right when you typed it in. Should the number be higher or lower than 50,000? And by 50, I mean 40. Lower, because it's decreasing. So some people will go and add the interest rate, and then they get a higher value, and they're like, that doesn't seem right, because it's not. So make sure that you subtract, okay? So I got 15,085.98. Make sense? Okay, then we're going to flip over. I want you guys to try this one. Try it out. This one's depreciating again, so we're going to have to. So let's look at this. We have, it was purchased, the excavating company purchased, has a digger that was purchased for 240,000, so that's my T1. It depreciates by 12%, so my R is going to be 100% minus 12% divided by 100, which equals 88% divided by 100, which is 0.88. And once I know my R, all my R does is I can take the previous term, times it by that, get the next one, right? Because R's you multiply to get to the next term, D's you add to get to the next term, correct? Remember that? For arithmetic sequences, you'd add your D, and to go the other way, you'd subtract your D. With R's, you multiply your R to go to the right, and then you divide your R to go to the left. Remember that? It's the same thing, it's just a word problem, right? So if I'm asking you for the next three terms, term 1 would be 240,000, right? Term 2 would be 240,000 times 0.88, because I just multiply by my R value. And I get 211,200. So that's the first of the, I need the next three terms, right? So I don't want the first three terms, I want the first four terms. Okay, when I say next three. Take that answer and times by 0.88, and I get 185,856. I need one more, times by 0.88, and I get 163,553.28. So it's just a geometric sequence, right? It's a word problem, which makes it a little more overwhelming, but still just a geometric sequence. I want us to determine the general term. General term of arithmetic sequences is the best, because you don't have to like distribute and collect like terms or anything. So we're going to have Tn equals T1, which is 240,000. R is 0.88, and n stays n. Tn would be the last amount since n, right? Years. If the digger was purchased in 2011, what's its value in 2017? So it's asking me to find T whatever, but I need to have an N, right? How do I get my N? I take 2017 I subtract 2011, which gets me the difference between the two, but I have to also still remember my end value, right? So I always have to add 1.
But then you just subtract it, so could you just leave it the same?
Pardon?
If you don't you subtract, like, it's n minus 1, so could you just...
You could technically just, oh, this is n minus 1. Sorry, this is the formula we use.
Okay.
This is the formula we use for 30-1, and then they make you do it with n minus 1 and 20-1, which is super helpful. So, all things. It's n minus 1. My brain just went to 30. So in 30, we would actually not add the 1. We'd go 2017 minus 2011 and put 6, because we don't fill it into this formula, we fill it into this man. But the geometric sequence formula has a minus 1. So we have to take them, subtract them, and add 1. And my brain has to remember that when I flop between 2 classes. Okay, so we're going to go T7 equals 240,000, 0.88 to the 7 minus 1, which is 240,000, 0.88 to the 6. Which is 111,456.98. So 2017, that's what it's worth. How long will it take for the equipment to be worth less than 100,000? So what's that? That's TN. And we know it's not SN because it's what the equipment is worth that. It's not like the total of it, right? So TN equals 100,000. And they want you to find N. So we can fill it into the general formula, which is 100,000 equals 240,000, 0.88 to the N minus 1. What do we have to do first? What did I tell you we have to do first? Yes, divide, always, right? We can't put those two numbers together. We have to divide. Exactly. So we're going to divide by 240,000. And then we don't want to use that as a rounded decimal, but we're going to have 100,000 divided by 240,000, which is 5/12, or approximately 0.41666, blah, 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 right? And I have 0.88 to the N minus 1. Next year, you're going to be taught how to solve these algebraically using logarithms. This year, all I can ask you to do is guess and check. So you can go like 0.88 to the 2 minus 1. So you could go 0.88 to the 1. Oh, that's not small enough. 0.88 to the 2. 0.744. Nope. 0.88 to the 3. Nope. 0.88 to the 4. Nope. 0.88 to the 5. Nope. 0.88 to the 6. Nope. 0.88 to the 7. And then 0.88 to the 8. Right? You could do that. Or what's a way you could do it so that it actually is more visual to you? This is the time where you could just keep going, right? And find out what year. It makes way more sense to you. This is really easy to do in grade 12 algebraically. For you guys, it's not. So the way that I would do it is, okay, in 2017, I know I have that, correct? And then I take that, and I times it by 0.88. And am I below that? Am I below 100,000? Yeah, it's like 98,082. So it's 2018. This is the point where I wouldn't, if it was a word problem, I would just use reasoning. And say, hey, in 2017, it was worth this. If I take that and I times it by 0.88, that gets me to 98,082.14. Okay, so 2018, I'll be below that.
So We wouldn't even like do.
You wouldn't
that
have
whole
to.
thing.
And the reason why I wouldn't push you to do it is because this is guess and check at this point. This is actual mathematical reasoning. I'd rather use mathematical reasoning at this point than guess and check, because this is a logarithm which is totally outside the scope of 20-1. To solve this, you would use a logarithm, and I'm not making you do it. Now, I will show you a way that you can do this to check it. You can type this into y1 and type this into y2. This is just for fun. This is to show you a little bit before grade 12. So in your y1 equation, in your calculator, you're going to type 5 divided by 12 in brackets. And in your y2 equation, you're going to type 0.88 to the exponent n minus 1. If your exponent pops up, you don't have to put the n minus 1 in brackets. If your exponent doesn't pop up, you have to put n minus 1 in brackets. Okay? This is just for a little glimpse of next year what you'll be able to do. Would I rather you just have the 0.88 see if it works? Sure. I'm just showing you a way that you can actually figure it out with your calculator instead of just guessing and checking. Okay? So at that point, you put this side into y1, the left side into y1, the right side into y2. Everyone got that? Now, if you press zoom, then 6, it sets your window to -10, 10, -10, 10. If you go zoom, the middle top button, and 6. It'll set your window to the nice window, just in case you've messed with your window recently. Zoom 6 sets your window to the -10, 10, -10, 10. So you don't have to do it. Okay? Now we want to press graph. We want to find out where those two equations cross each other. That'll give us the answer. How we do that is we go second, press the second button, then the trace button, because that's calculate, number 5, and then enter, enter, enter. And look for the n. What does the x say? What is your x? It should say on the little bottom of the screen. X equals what? Can I see yours? So you're going to go, into your equation. Does everyone have it in their y1, y2? So go second, trace, can I see your y equals? See in your y2, you have to have the other one. And instead of n minus 1, do you guys even know how to press x?
I don't even know what you're talking
This is
about.
so good. This is like learning. This is good because you guys have no idea how to use your calculators. It's scary. So that's okay. 20-1's calculator time.
I have a different calculator. It's like the same thing, but it's the Casio.
Here's the Casio. The Casio scare me, but you can still press the button.
Scare me.
So, to get this n, we're not going to use n. We're going to use x. There's an xt theta n button. It's down. It's right down below mode, I believe. That gets you dx. That's how you get the actual variable.
So 0.
So 0.88 to the exponent x minus 1.
Oh. Okay.
So you have y1 is 5 over 12. y2 you have 0.88 to the x minus 1, which you press the xt theta n button. That's how you get the variable. Because it doesn't have to be the letter n. It can be, look, the n is in there even, right? And then you go minus 1. So you type into y1 in the top left, this. Into y2, you type this. Did everyone do that? Does everyone have those? I'll show you after. I have to look at yours because I don't know the practice. So you go second, and then trace button, and then 5, and then enter, enter, enter. Then look at your x value. What does the x value on the bottom say?
Wait, and then, wait.
It says 7.8, which I'd have to round up to 8,
Wait, what
which
do you
this was 8 years. This was
after you press the second trace thing?
number 5, because you're trying to find out where the two intersect. And number 5 says intersect. And then you go enter, enter, enter. And it gives you 7.8. which actually has to be 8 years till it would get to be below that, right? Which would be T8, this is T8. Like this was T7, this is T8.
I'm just gonna stick.
You're doing it this way, totally, and I don't want you to do it the other way. Honestly, if I just taught you where the X, T, theta, N button is, we're winning. I've like taught you something that I feel like that's a win. Because you literally come from grade 10 to grade 11 with absolutely no calculator knowledge except for where the buttons are and how to multiply, add, divide. So if I can teach you where the Y equals button is, and I just taught you where the X, T, theta, N button is, I just won today. I don't even care what it is. That's a win. Because in grade 12 you use your calculators so much. And in grade 11 you'll start using them a lot too. You will. But if you know where the X, T, theta, N button is, walk away from this, and that there's a Y equals button, I have won. That's all I care about. Do I care that you can use your calculator to find these intersecting? Nope. Don't care at all. Because what would I have done? I would have said, hey, one more year got me below it. 2018. If you're doing more work than that, why? I don't even know what. Right? Our problems are hard enough as it is. But at least you now know there's an X, T, theta, N button, and you know there's a Y equals button. You can actually graph every graph on there. What's cool about it, I want to show you something that's cool. So go into your Y equals and clear up. This is life changing. There, so you go to Y equals and you just press clear. And you go down to Y2 and you press clear. You just clear them all up. Okay? Yet last year you did linear systems. You did lines, right? And you had to take your slope and you had to draw it and you had to put your y-intercept down and your slope and you drew a beautiful straight line. Correct? Or you had to do t-tables where you put an input in for x and you get a y and then you get coordinates and you plot them and then you make a line. Correct? Your calculator gives you t-tables. Wonderful. So in your y equals, type in a line. Let's type into y equals, let's type in x, which is the x, t, theta, n button, right? Plus 3. Just the line y equals x plus 3. That's what, I don't know why I'm still recording this. People at home do not need to know. Page 40, 10, and 12.